Good afternoon, ladies and gentlemen. Today we're going to talk about types of measurements and observations, and then scientific notation as well. After today, you should be able to distinguish between qualitative and quantitative measurements. Those should already sound familiar. Identify data as accurate or precise, and write numbers in scientific notation. A measurement is a type of observation. There are two kinds of measurements: qualitative measurements, which are descriptive. Examples include hot, cold, heavy, light, big, blue, furry. And quantitative measurements, which are observations made with measuring instruments and include both a number and a unit. Instruments could be like a ruler, a balance, a thermometer, or a graduated cylinder. Actual quantitative measurements would be 13.5 degrees Celsius, 25 kilograms, and 17 liters. Next, we're going to talk about accuracy. Accuracy means how close a measurement is to the truth or accepted value. Example, weighing a 50-gram mass. So I have three groups, or three different measurements here. The first measurement is 50.00 grams. That's very accurate. It's really close to 50. It is 50. The second one is 32.18 grams. That is not close to 50, so it is not accurate. And the last one's 49.99 grams, which is, again, close to 50, so it is accurate. Next, precision, how close multiple measurements are to each other. Example, take the weight of a 50-gram mass again. In our first group right here, it is both accurate and precise. There are three measurements of 50 grams, so 50 is close to 50, and all three measurements are the same. So it's accurate because it's close to 50. It's precise because they're all clustered together. The second group to the right is both accurate and precise. 50, we're close again to 50 grams, and all three measurements are really close together. Our last group is not accurate, but it is precise. So students measured the mass and they got 32.18 three separate times. So that's what makes it precise, is that they're all the same. But it's not accurate because they're not close to 50 grams. An easy way to remember: accurate equals correct. That's C is for correct. Then we have precision equals reproducibility. So the R, it's repeated or reproducible. Next, we're going to talk about scientific notation. Shorthand for writing very large or very small numbers. There are two parts: a coefficient and a power of 10. The coefficient is any number between 1 and 10, but not 10. So it's a single digit. And the power of 10 is the exponent of 10. If it's larger than 1, they're positive numbers or large numbers. If it's smaller than 1, the negative exponent means there are small numbers. This is how you go from a number to scientific notation. First, you would locate the decimal point. Next, you would move it to a location that will give you a number between 1 and 10, or 1 exactly. So you want one digit, you're going to move your decimal point to one actual digit, not a 0. Write this new number down, followed by times 10. Count how many times you had to move the decimal point. Use this number as your exponent. Decide the sign of the exponent. A large number means the exponent is going to be positive. A small number means the exponent will be negative. Any number from 1 to 10 makes an exponent have 0. So it would be, if it was 7, the example would be 7 equals 7 times 10 to the 0. Here are some examples. All right. So the following numbers we're going to write in scientific notation. Our first example is 41,000. Anytime you see a regular number like that, the decimal is always at the end if it's not shown. We want to move it so that there is one number in front of the decimal place. So we're going to move it between the 4 and the 1. My new number, my scientific notation number, is going to be 4.1 times 10. For our exponent here, we're going to figure out how many times we move the decimal place. So we start here and we go 1, 2, 3, 4. This is 4. We look at this number. If this number is larger than 1, this is going to be positive. If this number is smaller than 1, a decimal place, this is going to be negative. Okay? For number 2, we're going to move our decimal place between the 2 and the 9. So my new number is going to be 2.9 times 10. To find out my exponent, I see how many times I move this. 1, 2, 3. So this is 3. Okay. This number is smaller than 1. Therefore, this is going to be a negative 3. Go ahead and pause the video now. Try to do 3, 4, and 5 while you don't have the answers yet. Try to do 3, 4, and 5 on your own. Pause the video and then come back for those answers. Okay, continuing with the answers. We have 60,000. Like I said, the decimal's at the end. If it's not shown, we want to move it till after the 6. So my scientific notation is going to be 6.0 times 10. How many times did I move this? 1, 2, 3, 4. 4. And this is a positive 4 because this number is above 1. Because it's a large number. Number 4. Want to move my decimal to between the 1 and the 3. So my scientific notation number is going to be 1.32 times 10. To find out what my exponent is, I'm going to move how many times I move my decimal. 1, 2, 3, 4, 5, 6, 7. So this is 7. Figure out if this is positive or negative by looking at the original number. It's smaller than 1, so this is a negative 7. Our last example on number to scientific notation, we want to move our decimal place from the end to between the 1 and the 2. 1.23 times 10. How many times did we move our decimal? 1, 2, 3, 4, 5, 6, 7, 8. So that's an 8. Okay. So when going from scientific notation to a number, we're going to use the exponent to determine if the number is larger or smaller. Remember, positive exponents mean large numbers. Negative exponents mean small numbers. Using that positive or negative exponent decides which way our decimal is going to move. Okay? This is very important. If it's a positive exponent, it moves right. If it's a negative exponent, we move left. I would go ahead and write that down. Move the decimal point the number of times that the exponent says to. Write the number you now have. Okay? Here we go. We have 5 examples. I'm going to do 2. I want you to pause the video and then do the last 3. So the first one is 5.93 times 10 to the negative 3. So we have a negative 3. So we're going to move our decimal to the left 3. 1, 2, 3. And filling in with zeros. So we have 0.00593. Our next example is 3 times 10 to the 4th. That 4 is positive, so we're going to move to the right. Starts at the bottom, and we're going to move 4 to the right. 1, 2, 3, 4. Fill in with zeros. So we end up with 30,000. Okay. Go ahead and pause the video, do 3, 4, and 5. Make sure you can do them. And then come back to see if you got it correct. Continuing with the answers. Number 3 is 1.5 times 10 to the 3rd. That exponent 3 is positive. So again, we're going to move to the right. 1, 2, 3. Fill with zeros. Our new number is 1,500. Number 4, we have negative 2 as an exponent. So we're going to move to the left 2. Here's our current decimal. 1, 2. Fill in with zeros. So our answer, our whole number, is going to be 0.0621. Number 5, we have 10 to the 1. That 1 is positive, so we're going to move to the right. 1. Here's our current decimal. Move to the right 1. 75.1. That's the end of the presentation. You guys have 10 problems for homework. Please feel free to contact me with emails or through Hangouts if you need anything. Have a great day, guys.